Hello everyone, welcome to Intrinsic Intelligence YouTube channel. Today we are going to discuss in detail about CAP theorem, which is one of the system design in the distributed or the cloud environments. So let's deep dive into CAP theorem. So we will discuss on the history of the CAP theorem, how it evolved over time. So it is introduced in 2000 by Eric Brewer, and it is also called Brewer's theorem back then, and it slowly uh, came up into the existence as CAP theorem. So what Brewer's theorem or the CAP theorem explains is to design any distributed system, we need to have at most two guarantees. There are in a CAP theorem, C stands for consistency, and A stands for availability, and P stands for network partitioning. So what Eric Dever mentions is like the distributed system can always have or prioritize only two of the three principles. Either it should have consistency and availability, or availability and network partitioning, or network partitioning and consistency. Let's move on. So what is CAP theorem? So as we discussed earlier, so CAP theorem has three basic characteristics: consistency, availability, and partition tolerance. And a distributed network in general, as we all know, it will have multiple nodes. It could be virtual nodes, and it spans across regions across the world. As we all we are using the deployment using cloud apps, and cloud apps are mostly distributed across regions and countries. It depends on the client basis as well. So this diagrammatic representation will give some idea on what these three properties of CAP theorem mentions. So first, the consistency. What consistency states is like each client will always view the same data. So meaning if a client across any region in the world tries to view some data, it should be the most updated data in the system or the DB. What availability mentions is like, so as it is a distributed system, whenever the client requests some data, either the read or the write, the system should be highly available, even though it is a distributed, it is a distributed platform. And what is partitioning? Partitioning is like when a clients or the users try to read or update, there could be network failures, and there could be sync issues between the network. So the network partitioning should handle all the read and write requests. And the going back to availability, what it states that is like if you make your database or a system highly available, so whenever write happens, and when the client requests the data, so he or she might not seeing the most updated data, because we are ensuring the system should be highly available. So in that case, it will not be the most updated data. So that is one of the trade-off when we look for high availability. Whereas in consistency, the end user will see always the high, I always see the up-to-date data, because it waits for a write operation to complete and updates all the network partitioning. So if you need a system for high available to the customers, and you can always go for consistency and availability, or in case if it is not required, we can go for partitioning along with consistency or availability as a pair property. So so this is the first CAP theorem's property, consistency. So in a distributed system, like all the data in the nodes are same at the same time, regardless of which node the client is connected to. Let's consider like we have a application where it is being used throughout the world, and someone from one and someone in the country 10 or country 100 can also view the data, like country 1 and country 100, wherever the client is trying to fetch the data should see the same value at any point of time. So in other words, like we said, we should consistency is following the right operation, and then the future reads will happen. So it basically waits for the right operations to complete so that it can provide the most accurate data. So in terms of banking applications or databases, consistency is most required. And availability. So availability, what it mentions is like when a client requires the data, we do not make them to wait and receives an immediate response even if the network is down or some heavy write operations are happening. So this as we are reducing the turnaround time as much as possible, this could be like client may not see the recent data and if, maybe at the later point of time the nodes will be updated accordingly. So when a system prioritizes availability, like we should ensure like the data is replicated and load balancing is happened properly because the client will require the data as much as possible. There should not be any gap and it should be fetched faster. Partitions tolerance, as we discussed, network partitions or if there are network partitions in terms of cloud and distributed systems might face some delays, sync issues, or network might go down. So handling all the requests even if the network goes down, or considering a data distributed database system where a end user requests to multiple write or multiple read, or it could be combinations of read and write, the partition tolerance in a distributed system to ensure all the requests are served. So yeah, CAP theorem, we came to the end of the CAP theorem. So now the trade-offs, as we all know, like CAP theorem. So we all need consistency, availability, and partitions to be at the maximum level. But in a real case, we should prioritize and the third one is a trade-off, compromising the third property. As we discussed, either we should consider when we're designing a distributed system or a distributed databases, we should prioritize according to the requirement, whether we should go for C and A, consistency and availability, or consistency and partitioning. Yep. Yeah. So thank you for watching this video. And for more such videos, please do follow Intrinsic Intelligence and subscribe for regular updates. And I have also provided the GitHub repo link. Thank you once again and have a very good day.